Hey guys, so today we are going to be doing minimum spanning trees and we're going to be focusing on PRIM's algorithm in order to find a minimum spanning tree. Alright, so let's get into it. Alright, first of all, just remember, for a minimum spanning tree to exist, all vertices of the network need to be connected, and you also can't have any loops or cycles. So they're two important aspects to remember. Every vertex has to be connected and you can't have a loop. Okay, so what does an algorithm mean? Now, an algorithm is literally just a set of steps to solve a specific problem. And I personally like to think of it as just a recipe. So if you think of a recipe, it always goes step 1, 2, 3, 4, all the way till the end. And you should always get the result you're looking for. So for example, I've got a simple algorithm for making a peanut butter and jelly sandwich. So step 1, get 2 slices of bread. Step 2, put peanut butter on one slice of bread. Step 3, put jam on the other slice of bread. Step 4, put the slices of bread together with the peanut butter and jam facing one another. And step 5, cut the sandwich half diagonally. Done. So as you can see there, it's just a set of simple steps such that step 2 depends on step 1, step 3 depends on step 2, so on and so forth. So this is an example of an algorithm. Now how we're going to use an algorithm for PRIMs is actually quite straightforward. So PRIM's algorithm is just one way or a recipe used to find a minimum spanning tree of a network. Alright, so here we go. Step 1, start with any vertex as the root of the tree. So here you get a bit of option here. You can literally start at any vertex. Step 2, find the edge with the smallest weight that connects to the tree to the vertex that's not in the tree. So basically what you want to do is look for the next smallest edge that's already within the tree you've started. Now make sure there's no loops as always, and then step 3, you just repeat step 2 until all the vertices are done. Okay, so let's have a look at some examples here. Alright, so remember, PRIMs tells us we can start at any vertex. So I'm literally gonna just start with K here. Now we want to choose, so step 2, now we want to choose the next smallest edge that's already connected to what I've got highlighted here. So our only options here are 12, 8, and 5. So obviously the next smallest edge is going to be 5. And now I just repeat the process of step 2. So I find the next smallest edge that's already connected to either K or M. So what are my options? I've got 12, I've got 8, I've got 9, I've got 7. So the smallest number there is 7. Connect that there. Repeat step 2 again. So what's the next smallest edge? I've got 12, 8, 9, 10, and 6. So it's going to have to be 6. Okay, so I'm just missing one vertex, and just by looking at it, I've got 12, 8, 9, 10, 11 to connect to A, so obviously 8's our smallest, so that is going to be our minimum spanning tree there. Now, if you'd like, obviously when you're doing exam questions, you'll have to redraw it, so just quickly, it should look like this. I think I've covered everything there. Now, obviously, if you want to find the weight, you would just add all your, well, not the A, you'd add all your edges to find the weight of the minimum spanning tree. Okay, let's look at the next example. Alright, so once again, start with any vertex you choose. So let's just switch it up and start in the middle. So what's the next smallest edge that's connected to P? So I've got 7, 5, 12, 6 to choose from. So it's going to be 5. Repeat the process. So what are my numbers that are, what are my edges that are already connected to either P or A? So I've got 7, 9, 8, 12, 6. So it's going to be 6. Next one. So what's already connected to A? 9, 8, 7, 12, 10, and 9. So my smallest one, it looks like, will be 7. So connect that there. So how many vertices do I have left? 1, 2, 3. All right. So the next edge that's already connected within my network, just by looking at it, looks to be 3. So 2 more vertices to connect. So what are my options? I've got 8 and 12 or 10. So 8 should be my smallest edge. And then lastly, to connect Q, it has to be 5. So that is my minimum spanning tree for that one, using PRIM's algorithm. It's pretty straightforward. So let's just do one more example just to be sure. Okay, so this one's a little bit more complex, but we got this. So let's start up here at E. Now I'm going to work through this a little bit faster, but let's see if we can't get this done. So the next smallest one that's connected is 3. The next smallest one that's connected already looks to be 4. Okay, so here you can see you've got 2 options. You've got 4 and you've got 4 there. Now, so as long as it doesn't make a loop, you can go ahead and do them simultaneously. So I'm going to have 4 there, 4 here. All right, cool. So moving forward, what's already connected, it looks like the smallest number. I think that's going to be this vertice or this edge here. So 3 goes to A. The next smallest edge that's already connected. So, all right, now 5 is going to form a loop, so I'm not going to choose that one. I've got 6 up here, or I've got 4 down here. So I think 4 will be the next smallest edge out of all these ones that I could connect. So I'm going to choose that there, 4. Okay, so I think we're going pretty well. Now we just need to connect 1, 2, 3 more vertices. So the next smallest one here has to be 2. The next one after 2, it looks like it's going to be P to H, which is 6 there. And then lastly, here you have 2 options. You can either do this one, this 7, or this 7 here. It really doesn't matter. Okay, so I'm just going to choose this one here, and that will be your minimum spanning tree. Now your minimum spanning tree might look different depending on what algorithm you use, but the weight should always be the same. Okay, cool. So that's it for this video. We've also got another video where we're going to do Kruskal's algorithm, and once again, it's just a different method and a different step of, or different recipe to get you the same result. All right, cool. So if you have any questions, leave them down below. Otherwise, I'll see you in the next one. Peace.